Hey folks, today I'm going to do a quick how-to guide on how to use entity framework migrations. First, I'll talk about what migrations are and why you might want to use them, and then I'll show you how to create migrations, use those to update your database, and if needed, remove and revert those migrations. So first, what is entity framework migrations and why would you want to use it? Entity framework migrations is a way of taking entities that you're already using in your code for your different data objects, and then using those objects to update your database schema. In this demo today, I'm using what is referred to as code first migrations, and that just means that the entities in your code are the source of truth. So the entities that you use in your code are then transformed and created into migrations, which can update your database. So let's go dive in and get started. .NET provides a set of tools that will create these migrations for us. So we need to make sure that's installed on our computer. So in order to install that, we can just copy this command and run that in any terminal. So I've copied that command in my terminal. I'll just make sure that's installed. And you can see that I already have it installed, so this isn't going to do anything for me, but you'll need to run this if you haven't used it before. Now let's go ahead and jump into our API and see what changes we need to make in order for this to work. So here I have a very simple .NET API. This is in version 7. I don't have any controllers set up, any repositories or anything like that, but all I have right now is two entities, a person and an address. I'm going to show how migrations can take these two objects and turn them into tables in our database. In my example here, I'm going to be using Postgres as the database, but migrations work with other SQL databases too, like SQL Server and MySQL. Since this is a brand new project, we need to do a little bit of prep work before we get started. We need to install a couple Nuget packages, and we need to put a connection string in app settings so that it knows how to connect to our database. So first, let's go install those Nuget packages. I also want to point out that I'm using JetBrains Writer for this, so if you're using Visual Studio, some of this stuff may look a little bit different, but the concepts are all still the same. So the first package we need to install if you're using Postgres is the Entity Framework Core Postgres package. And I'll have a link for this down below. So we'll search for this, go ahead and select it and install it. And the second package we need to install is the Entity Framework Design package. So search for that, do the same thing, install that. So now let's head over to the app settings file. And in our app settings file, I'm going to add a new connection string. So this connection string here is just pointing to a database on my local machine. And this database is actually running inside of a Docker container. And so if you're interested in knowing how to do that, I've done a video on that. So I'll put a link here if you want to go watch that. So now we have our NuGet packages installed. We have our connection string set up. Let's go ahead and start adding a couple of the files that we need to make this work. Now we need to add what's called a DB context. A DB context is a class from Entity Framework, and this is basically a class that is the bridge between the entities in your code and how it connects to the database. This DB context can do a lot, but in this example here, we're only going to use it to do a little bit of configuration and add our tables. So I like to put mine in its own directory. I'm going to put it in a directory called data. I'm just going to add a new class, and I'm going to call it efdemo db context. And this is going to inherit from a class called db context. So I just hit tab there and Writer automatically imported the using statement that I need. So we need to make sure that this gets added up here using Microsoft Entity Framework Core. And then we need to tell the database context how to configure itself. I'm just going to paste in for my cheat sheet over here. We're going to override a method called onConfiguring. And there's a lot of stuff that you can do in here, but the main thing we're going to do is we're going to tell it to use the Postgres package that we imported earlier. So this is how you tell it which database to connect to. And what we also need to put in here is the connection string. And since we put that connection string in our app settings file, we need a way to get that back out of that file. And .NET provides an easy way of doing this called configuration. So in order to use that configuration, we need to inject it into our DB context class. So the first thing we need to do is create the constructor for this. So one little tip, and I think Visual Studio has the same command. If you type CTOR for constructor and hit tab, it'll automatically fill in that constructor definition for you. So then we need to inject that configuration. So that is just iConfiguration. And I'm going to give it a name of configuration. I'll show another really cool trick. And I'm on a Mac, so the command is command period, and then it'll bring up the context menu. And here you have a couple different options. And if you choose introduce read-only field, that will create a private read-only field up here with the same name, and then it will assign it right here. Now that we have a reference to configuration, we can use that to get the connection string out of app settings. And so inside this use npg SQL method, if you type configuration .get connection string, you can just pass in the name of the connection string. In my example, I'm using efdemo. So if you hover over this get connection string right here, you can see that in the description it says it's shorthand for get section connection strings and then the name that you pass in. And so what that means, it's going to look for connection strings, and then it's going to look for the name that you pass in, which in my case, I used EFDemo. So now our database context knows what database to connect to. And so now we need to tell it what entities would map to tables in our database. And the way that you do that is by defining a DB set. So I'll say public DB set, and I'm going to give it the name of my class. So I'll start with person, hit tab, so that will import my using statement. I'm going to name it persons, and then I'll just add the get set. So I'm going to copy that, and I'm going to do the same thing for address. And so now our database context knows that we have two tables, a persons table and an addresses table. And it knows that the persons table is actually using this person entity, and the addresses table is going to use this address entity. So now let's go jump into these entities and see what they look like. So first in the person entity, like I said, these are all super simple. So all I have is an ID, a first name, last name, and then a list of addresses. And I just did a list of addresses just to kind of show how a one-to-many relationship would work here. And then in the address entity, I have an ID, person ID, so that you can link it back to the person, address 1, address 2, city, state, and zip. So since we have a one-to-many relationship from a person to an address, it means that every address would belong to one person. That's what this is defining right here. And so before we make any more changes, I want to show you how to create a migration and just show you the magic of Entity Framework and how it takes everything we've defined here and turns it into a migration. And then after I show you the output, I'll show you how we can make changes to this to make it the way that we want it. So to create a migration, we're going to use that .NET EF tools tool, that's kind of weird to say, to create that migration for us. So let's go ahead and open up a terminal. I'm going to use the terminal that's inside of Writer, but this can be any terminal as long as you're in the folder where your project lives. So the command we need to use to create a migration is .NET EF migrations add, and then we just give it a name. So I'm going to say it's initial migration. I'm going to run this, and you can see that it failed. It says no project was found. And so there's two ways that you can fix this. Either you can run this command from the folder that has the project in it, or you can pass the folder name into this command. So I'll show you both ways of doing that. So if you want to pass in the folder name, you can see up here above, there's EF migrations demo. So if I do -p for EF migrations demo, and then I run this again, it's going to start the build and it's created a migration. So that's one way that you can do it. The other way that's a little bit easier actually is you just CD into that same folder. And then you can run the command without the -p on there, and then this will work as well. So since this one that we ran earlier did succeed, you can see up here it created a new folder called migrations. And now there's two files in this. There is an initial migration file and this EF demo DB context model snapshot file. I'm going to come back to the snapshot a little bit later and talk about that. So let's first just look at the file that it created for the initial migration. So this creates a new file, which is a C# class that inherits from migration. And inside of that are two methods. There's an up command and a down command. So first let's start with the up command. And what this does is this tells Entity Framework how to create this migration, what to go build and apply to our database. So you can see the first thing it does is it creates a table. The name of the table is persons, and then it creates a bunch of columns. So it has the ID column, the first name column, and the last name column. And you can see here that it inferred a lot of things about what it thinks these columns should be. So it's creating the ID field as an integer, it's non-nullable, and you can see here that it's telling it that it's going to actually create this as the identity column. And then for first name and last name, it made them as text fields and it made them non-nullable. So if you're looking at this, you're probably thinking, first of all, well, how did it know all of those things? And how did it know to create the ID as the identity field? And why did it create these as texts? And why are they non-nullables and all of these things? That's the magic of Entity Framework. And so I'll come back to that in just a minute. So if we keep going down here, you can see that there is constraints for the table. So it creates a primary key called PK_persons on the ID field. And then it creates the addresses table. Got a bunch of columns, ID that's created as the identity field, person ID, address 1, 2, and 3, city, state, zip. And then you can see down here, it created constraints for this table as well. It has a primary key for the ID field. And then it also defined a foreign key, which is a definition of the foreign key between the person table and this address table. And then you can also see that it created an index on the addresses table on person ID And this is pretty standard practice in databases to create an index on the foreign key of a table so that when you join persons to addresses, that lookup is much faster. And it can join those two tables together much quicker. And then down here at the bottom is the definition for the down method. The up method was for creating everything, and the down method is for removing things. This is the cool thing about migrations, is you can do these incrementally to build up your database. But if you screw something up, if you define your down methods correctly, you can actually reverse some of those changes that you made. So as I mentioned before, there's a lot of magic that happened here. And one of the things that I remember being really confusing about this when I first started using migrations is, how did it know that the ID field is the identity field? So if a field that has ID or the entity name, in this case, person ID, it's going to assume that that is the primary key. And that's why it created this ID property as the identity column. And a similar logic is applied for foreign keys. So in our addresses table, we have a column called person ID. And this property has the name person in it, which is the same name of the property that we're using for the class of person. So it's going to assume that this person ID is a reference to the person object for the address. And then it makes a lot of assumptions about individual fields. So a lot of our things that are strings were just made into text fields because it doesn't know how big they should be. So it's just going to say, sure, I'll make them as big as they need to be. And by default, they're non-nullable because we didn't define those properties as nullable fields. So we wouldn't want to apply this migration to our database because this isn't the way that we want this table to look. So let's go ahead and remove this migration, fix a few of these things on our entities, and then we'll create another one. And since we haven't applied this migration to our database yet, it's super easy to remove a migration. So if you just say .NET ef migrations remove, and this command will remove the most recent migration file. So if I go ahead and run this, you can see it's removing that migration. And since that was our first migration, it actually just removed that file as well as the snapshot file. And the way that it knows which one is the most recent migration is by how it names these files. So this is actually the date. So it's currently 2023, it's February 24th, and then this is a timestamp. So as you create more and more migrations, they will automatically be sorted correctly because they will be ordered by the name of that file. So let's jump into our person object here and let's make a few changes to this. So if you're familiar with Postgres, you know that if a column has a capital letter in it, then when you're using SQL to query that column, you have to put it in double quotes. And some people might like that, some people might not. I don't like doing the quotes around the fields. And so I do all of my columns in what's called snake case. So they're all lowercase and the words are separated by an underscore. And that same thing also applies to tables. So you can modify all of these things in this entity using what's called an annotation. So above our class definition, we can add an annotation for table. And when I hit tab there, you can see that it imported this using statement, system.componentModel.dataAnnotations.schema. And the arguments for this is just the name of the table. So I'm going to call it person. And by doing this, this is telling that instead of calling this table person, or I think it pluralized it, and made it persons, just call it person. And then you could do similar things with all of your columns. So column, and you can say, I want this to be person underscore ID. And so I'm gonna go ahead and just really quickly apply this to all the other fields as well. So I made these first underscore name and last underscore name. Now, one of the other things we need to change is that it created all these string fields as text fields, and we don't want our fields to be that big in the database. So another annotation you can add is max length. So I want the maximum length of the first name field to be, let's say, 100 characters. So if I add that to both first name and last name, these will now be a max length of 100 characters. So since it's so easy to add and remove migrations since we don't apply them to the database, let's just add this migration again and see what it looks like. I'm going to say .NET migrations add. I'm just going to use the same name of initial migration. I'll run that. It will spit out this initial migration file. And so now you can see create table, the name is person, and the columns are now person underscore ID, first underscore name, and last underscore name. And so now you can see that the first name and last name now have a type, character varying of 100. So this is great. So this means that these two columns aren't going to be gigantic in our table, and this is much better database design. So let's go really quick and do the same thing for address. I want to map this to table. I'm just going to call it address. I also want to point out that there are more options in these. So if you wanted to, you could also define a schema for these. And so just for fun, I'm going to put a different schema on this address table just to show how that works. So I'm just going to create a schema called add. So now this table will be add.address instead of public.address, since public is the default schema for Postgres. And then I'm going to do the same thing for the columns. Okay, so now I've added the column names for these, and I'll go in and add max lengths for these as well. I did 100 for address and city, and then for state I did 2 and zip I did 5. If you remember, it also added all of our fields as non-nullables, and that's just because we didn't define these fields as nullable fields. The easiest way to actually do that in the entity is just to make it a nullable. So if you add a question mark after the type definition, that makes that a nullable field. So address 2 isn't always going to be a required field, so I will just put a question mark on that so that it makes it nullable. I'm going to remove that last migration I did as a quick demo, and I'll recreate this initial migration with our changes to address, and we'll take a look and see how it looks. So here's our new migration, and you can see that since we added that add schema for the address, one of the first things it does is say make sure that schema exists. Here's our changes to the person table, and here's our changes to the address table. So now it's called address with the schema of add, with our new column names, and you can see here that it applied the correct types for our string columns. And then you can see here that for address 2, this is now nullable. So you can put in a null value into this column and it won't get mad at you. Let's say that with these changes, we're ready to apply these to our database so that we can start using it and see if there's any issues. When you're doing this on a local database like I am, this is a great way to test and see if your code's working the way that it should be, and if the database is set up in the way that it should be. And luckily, the dotnet tools CLI gives us a really easy way to update this database. So if we go back into our terminal, the command to update the database is .NET EF database update. I'm going to add one more little property on here. I like to do -v, which means verbose logging. And this verbose logging switch just makes it so that it prints out all the stuff that's doing, and so you can look and see what's going on. So I'll go ahead and run that. So now let's go look and see what was actually done into our database. So here I'm using Azure Data Studio. I have a connection to this database called EFDemo. I'm going to expand databases. Here's the EFDemo database that we just created with that command. So if we expand tables, you can see here's our add.address table. Here's public.person. And here's another table called public__EF migrations history. So I'm just going to go ahead and select everything out of this table. And you can see in here that it has 2 fields, migration ID and product version. And so if you look at this migration ID, that should look familiar. This is the same name of the migration that we created earlier. So if I go back into our project, you can see under migrations, that's the name of the migration that we created. And this is how migrations knows what has been applied to a database and what has not. When a migration is successfully applied to the database, it puts a row in this table saying that that was applied, and then it knows to not apply that again. So now we have successfully created the DB context, we've created our first migration, and we've applied that migration to our database. So now let's take a look at creating another migration and applying that one. So let's say that we want to add another field to our person table. Let's say we want to add date of birth. So let's add a public date time called date of birth with a get set. Let's go ahead and change the name. This will be date of birth. So now we have this new field for date of birth. So let's go create a new migration with this and see what that new migration looks like. So same as before, I'm going to say .NET EF migrations add. This is just going to be date of birth. So it said it successfully created a new migration, so let's go take a look. So here there's a new migration file called date of birth, and inside of that you can see that in our up command we added a new column. The name is date of birth, it's on the person table. The type is a timestamp with time zone. It's not nullable. So one really interesting thing about when you add new migrations is how did it know only to add this column and not to add all the other stuff too? Well, I skipped over this before, but this is where the snapshot file comes in. So this snapshot file is literally a snapshot of what your database should look like at the current point in time. And when you add and remove migrations, this is what any framework uses to know whether or not different things should be added or removed from those tables. And if you look through this file, you'll see the definition of all of our tables and our columns in the current state according to the migrations that we've created so far. So you can see here's the address table, there's the ID, address 1, address 2, etc., etc. And down here on person, you can see that now it has date of birth in here. And this is in here because we've created the migration. Even though we haven't applied it to the database, this is the current snapshot for what we have in our project right now. Just to show that this will change, I want to go back and I'm just going to remove that last migration. So I'll do .NET EF migrations remove. So you can see here that date of birth migration is gone. And now if I go into the snapshot and if I look at person, you can see that that date of birth column is no longer here. So if I go back and redo that migration and I recreate it, it's going to look in here and it's going to say, oh, there's a new column called date of birth. I don't see it in here, so that means they're going to add it. So that's how it knows what to create and what not to create. So really quick, I'm just going to go back and add that migration back in. One thing I forgot to mention earlier in the video is when you create migrations, you always want to review the migration that's created. And you do that for the exact reason that we did it to begin with, because we noticed that all of our strings were text fields and our columns had capital letters, and it's not quite the way we want it to be. So always review the migration file, make sure it's exactly the way that you want, because you can revert migrations, which I'll show a little bit later, but it's a lot easier if you don't have to. I've recreated the migration for date of birth. I want to go ahead and update this database again so that now we're going to apply the migration where we added date of birth. If I go over to our database, and if I re-query this migrations history, you can see now there's another entry in here for date of birth. And so now our database has recorded that that migration has been executed. And so if I go over and look at person, you can see it has a new column, date of birth. So now let's talk about reverting migrations. Let's say that we've added this date of birth migration and we find out that something wasn't right. Either the column name or the type or whatever it may be. How do you get rid of it? Well, there is a way to get rid of migrations and to revert them. And earlier we used .NET EF migrations remove to remove the migration. And I just want to show what that will do with the date of birth migration already added. So if I try to remove this, it's going to say that migration has already been applied to the database, revert it and try again. Any framework is smart enough to say you don't want to remove that migration because you've already applied that to the database. You need to actually roll it back and then you can remove it. The way that you revert migrations is actually pretty easy. Now, I do want to state that you want to be really careful about doing this if this has been pushed to a production database. Since this is local and we're doing development, you can add and remove, revert stuff as much as you want. It's not going to cause any problems. But when this is on a production database, just be really careful about doing this. So in order to revert to a migration, we want to run the .NET EF database update command again. But this time we're going to pass in the name of the migration that we want to go back to. So in our case, we want to go back to the initial migration, which is going to roll back or revert our date of birth migration. So I'm just going to say initial migration. I don't think that you need to put in the full name here. Let's try this and make sure this works. This is what I love about having the verbose logging on here is there's a lot of stuff in here. So you can see here that it altered the table person and it dropped the column date of birth. And then you can also see that it removed that migration from the EF migrations history table. So now if we go back into our database, let's rerun, see what's in migrations. Now you can see that migration for date of birth is no longer here. And if I refresh the columns for person, you can see date of birth is gone. So that's how you revert a migration that has already been applied to a database. And after you revert a migration, you also need to remove it so that you can change it and re-add it. So you can see that it reverted the migration, but the migration script is still here for date of birth with the stuff that we don't want. So now we can rerun the command to remove it. And so this removes the migration from our development. So from our local development project, it's going to remove that migration. So now we can go back in. Let's just say that it's supposed to be birth date instead of date of birth. You can save that and then you can rerun it and update your database. And so the last thing I want to show you is different ways of applying these changes to the database. So we used the .NET EF database update command, and there's two other ways that you can do that. One of those ways is by telling .NET to create you a SQL script. And it will actually generate the raw SQL that you can use to then run and update your database. And the other way is what's called a bundle. And the bundle is basically just an executable package that you can run and go update the database. So first I'll start with the database script. So if you run .NET EF migrations script, I'm going to say -o. This is a switch to tell it the output. So I'm just going to say script.sql. So now if you look in our project, now there's a SQL script in here. And so if you open up this script file, you can see that this is just plain old SQL. And so you could look through this, you can make sure everything looks correct, and then you could take this and go up, run that against your database. Now the one downside to how this was created is that if you run this against the database and then you add another migration and you create a new script and you run the script, that these are all still going to be in here. So it's going to try to create the table for person. It's going to try to create the person for address. And that's not what we want. I'm going to remove that file. And so we're going to add one very important switch to this script command here. which is -I, which stands for idempotent, and easier to show how this works than to explain it. Idempotent just means generate everything, but make it so that it doesn't rerun the commands against the database again. So now that you can see that for every single command in here, it's going to go look and say, has this migration been applied to the database yet? And if not, then go do this. And this is probably how you would want to run these SQL scripts if you do it this way, just to prevent accidentally having issues when you try to update the database. And then lastly, I'm going to show how you can use bundles. And so the command to create a bundle is .NET ef migrations, and then bundle, and same as before, -O, tells it where to put it, the output file. And then I'm going to also add this, which is self-contained. So we'll go ahead and run that, and that created a bundle for us. So now if we go look in our project, there's this bundle file. This bundle file is basically an executable program that you can run that's going to apply these migrations to your database. And since I ran this on a Mac, it's going to create an executable that the Mac can run. If you're on Windows and you run this, it's going to create an exe file. And so now you can take this bundle and you can run it, and it's going to execute those migrations against your database. And also the reason I ran that with the -- self-contained, this bundle package needs the .NET runtime in order to run. And so if you say -- self-contained, it's going to actually package all of the stuff from .NET into the bundle that it needs. That way you could run this on a machine that doesn't have .NET installed on it and it would still work. So now I'm going to go ahead and run that. So if I do /bundle, because I'm in the folder where that bundle lives, one of the things you can pass to it is the connection string. And this is kind of one of the cool things about these bundles is that you can create the bundle and then you can go apply that to any database that you want. So you could run it against your local database. You could use the same bundle to go run it against your dev database, and then your test database, and then your production database. And that's just a really great way of saying that this bundle is created and I know it's not going to change, and I can run it against all of my different environments, and that way they're all the same. So I'm just going to hop over to app settings. I'm going to copy that, paste it in here. This is a connection string to my database. If you run that, you can see that it applied the migration for date of birth. So this demo here was actually just scratching the surface of what migrations can do. So I'll put a few links down below to Microsoft's documentation on all the different things that migrations can be used for. If you're interested in seeing even more about this, let me know in the comments down below. Maybe I'll do a more advanced video in the future. If you like this demo and you found this video useful, please consider liking and subscribing. It helps me out quite a bit. And I appreciate you sticking around to the end. So thanks for watching, and I'll catch you later.